Ideal gas law. The ideal gas law compares pressure, volume, moles, and temperature. And there's a gas constant known as R. Now know this! All of your units should be atmospheres for pressure, liters for volume, N is moles, and our gas constant, which is R, is this value with liters times atmospheres all divided by moles times Kelvin. And our temperature is always in Kelvin. Now that you know this, let's move on to our example. What volume does 0.556 moles of gas occupy at a pressure of 715 millimeters mercury and a temperature of 58 degrees Celsius? Let's identify our given and what we're finding. Our given is moles, pressure, and temperature, and we're finding volume. Step 1, convert to your proper units. Using our temperature in Celsius, we want to convert this to Kelvin. We'll add 273 to get 331 Kelvin. Now let's change our pressure into atmospheres. Remember, 1 atmosphere equals 760 millimeters mercury. This is our conversion factor that will allow us to get from millimeters mercury to atmospheres. We'll align the millimeters mercury so they can cancel, and we'll be left with just atmospheres. After we divide these two values, we get our new pressure in the proper units. Step 2, plug it into your formula of PV equals NRT. We'll plug in our pressure in the proper units of atmospheres. Then we'll multiply that pressure by our V or our volume, set this equal to our N or our moles, then multiply by R, which is our gas constant, which is this value. And lastly, we'll plug in our temperature, which is in Kelvin. Next, multiply each one of these values. Now that we've multiplied the right-hand side out, we want to divide this over to get V by itself. After we divide these two values together, we get 16.05, but we want to round to 3 sig figs since our original given values were exactly 3 sig figs. Our final answer is 16.1 liters.